So let's try and find out velocity at point B and acceleration at point B, and later on would be finding tension at point B. Alright, so right now our mission is velocity VB and acceleration. Alright, now when it is moving this way, when the point mass is moving in a circular motion, vertical circular motion, what happens? Now in case of vertical circular motion, as soon as it comes over here at point A, the particle gains height. How much height does it gain? It gains r plus r, 2r height. So we know formula for potential energy is mgh. So at this point, the potential energy gained by the point mass would be mg2r, the height. Alright, and as it comes from here to this place, that entire potential energy gets converted into kinetic energy. The potential energy gets 0 over here, the value of 0 potential energy. Alright, whereas kinetic energy would be half m vb square. Alright, okay, so that's what is keeping on happening. And why is it happening? Because of conservation of energy. Alright, so we all have studied about conservation of energy. Fine. In order to get VB, we have got to apply conservation of energy theory. Alright, so how? So gravitational potential energy decrease is equal to gravitational kinetic energy increase. Where? Obviously, we are talking in terms of this and this. So gravitational potential energy decrease. How much is the decrease in gravitational potential energy? It is mg2r. Alright, mg2r got decreased. And how much is increase in potential energy? It is half m vb square minus half m va square. That is difference in kinetic energies. Whatever is the difference in kinetic energy between these two, obviously even at this point it has kinetic energy, and even at this point it has kinetic energy, though the tension is pretty low, nearly 0 here, but it has kinetic energy, that's why it moves. So there is difference in kinetic energy in between this point and this point is equal to gain in potential energy at this point. The equation is set. So now what happens? What we do is we multiply this throughout by 2. Alright, we multiply throughout by 2. Alright, so obviously what happens is this cancels, this becomes 4. So it becomes 4. Then we also know m also cancels. So what we are left with is 4rg is equal to vp square minus va square. Alright, so vp square is equal to 4rg plus va square. I took va square this side, right? 4rg plus va square. We already have found out va to be root rg. So we substitute here, root disappears, rg added to it. So vb is equal to root 5 rg. Alright, so we got root 5 rg. Centripetal or centrifugal force is mv square over r. So if it is acceleration, we divide it by mass. So this becomes the acceleration. Alright, formula for acceleration is v square over r. So instead of v square over r, we write it as vb square over r. Vb square right now found out is vb found out is root 5 rg. So vb square is 5 rg. So r goes. So what we end up is 5g. So acceleration at point B is 5g. So vb found out at point B is root 5 rg and acceleration is 5g. So the methodology used for finding vb was gravitational energy, conservation of energy. Whereas here for acceleration, we just used the formula mv square over r, that is force, mass removed, v square over r is the acceleration. Applying that, we got acceleration.